So today I'm going to be talking about acid properties and nomenclature. So basically acids are substances that ionize when they're dissolved in water or break apart. And this yields hydrogen ions, positive hydrogen cations, which makes them very reactive with other substances. As you can see down here, all acids contain this hydrogen here. And they act like ionic compounds in that you have this positive hydrogen ion with these negative ions, like hydrochloric acid, you have this chloride ion. Nitric acid, you have this nitrate ion, and so on. And the state of acids is aqueous, or AQ, which means dissolved in water. And this is what we would use for writing states and chemical reactions of acids. And when you're looking at acids, one of the big characteristics they have is their concentration, which is measured as pH. And as you can see the pH scale, it's 0 to 14, and 7 is the neutral number. And when you decrease, the numbers decrease, you get more acidic, with 0 being the most acidic, and you see hydrochloric acid there. And then as numbers increase, you get more basic, with 14 being the most basic, with substances like bleach or drain cleaner. And to calculate this pH was not really important, but in the future it may be, is the negative log of the hydrogen ions in the solution, or this aqueous solution that you have with this acid. And the composition of an acid is pretty simple. You have the cation, which is this hydrogen ion, and you have one or more of these positively charged ions. And the anion on the other side, there's two choices. You have a polyatomic ion with this hydrogen ion, or usually an oxyacid, such as sulfate, which contains oxygen, it's actually acid, or you have a binary acid, which contains one nonmetal anion, such as chloride, bromide, iodide. It's just this individual thing that is paired with this hydrogen ion. And writing acid formulas is completely the same as ionic compound formulas that you learned in the past. And you simply just crisscross the charges. And of course, hydrogen ions are positively charged with a 1+, so that makes it much simpler. And so you have HSO4 here. And you have a 1+ charge on the H and a 2- on the SO4. And you simply crisscross and you get sulfuric acid, H2SO4. And to name binary acids, it's pretty simple. So of course, you're going to see that there's one ion with the hydrogen, such as chloride or sulfide, as you see on the bottom. And so if you see if you can identify this binary acid, you're going to add hydro as a prefix before. And then you're going to add the root name of the anion. So usually the name is chloride or sulfide, as you see in the bottom here. But then we just take out the chlor, because that's the root name. The ide is similar in all these, but the chlor and the sulf are what's unique, and that's what we'll take after and put after the hydro. And then you add the suffix ic, IC, and then add acid. And that's pretty simple for binary acids. And then oxyacids are a bit more complicated. So first you're going to add the root name of your oxyacid. So usually you have, up here you see number 1 here, you have chlor, perchlor, hypochlor. This is for like all the names of chlorate, perchlorate, perchlorite, hypochlorite. And you're going to take out the root name just like binary acids. And then next, you're going to determine the suffix of the polyatomic anion. So it's either 8 or ite, as you know, sulfate, sulfite, which determines the number of oxygens. So you can identify that from the number of oxygens. And then you're going to change the suffix, which is the important part. And so if this polyatomic ion's name ends in 8, you go to ic. And if it ends in ite, you go to aus. So just remember that, 8 to ic and ite to aus. And remember to keep the per and hypo prefixes if you have them, like hypochlorite or perchlorate. And then add acid at the end again, just like binary. So overall, here's a good here's a good table to look at. So here's your unique individual ions that you'll see: perchlorate, chlorate, chlorite, hypochlorite. And then remember this 8 going to ic, 8 ic. And then you have the ite to aus, chlor-aus acid. And then hypochlorous acid. And we're keeping that prefix, per and hypo. But we're changing the end, 8 to ic and ite to aus. Now take a second, pause the video, and try some of these. Alright, so first one, you can see it's a binary acid because it's one hydrogen ion and one bromide ion. And it's one other ion, which is bromide, one other type. So of course you're going to do the binary acid nomenclature, which simply means you're adding the hydro. You're taking the root of bromide, which is brom, and then you're adding ic and then acid at the end. And then number 2, you have another binary acid, which is because you have one type of ion afterwards. And so you're adding hydro at first, then you're taking the root of iodate or iodide, which is IOD as you see here, taking out the ide, and then you're adding ic at the end and acid. So now number 3 is you have a polyatomic anion. So what you're going to have to do is determine the name of this to determine the name of the entire acid. And we know phosphorus is not in the elbow, so this would be phosphate because there's 4 oxygens. And remember, 8 goes to ic, so you would have phosphoric acid. And here, number 4, again, we're just going to determine the name of this anion. And of course, chlorine is in the elbow, which means chlorate has 3 oxygens, chlorite has 2, and hypochlorite has 1 oxygen, which is what we have here, hypochlorite. And remember, ite to -ous, so we have keeping this prefix, hypochlorous acid. And then we're going to try writing the formulas for these. So the first one, you see hydro at the beginning, so you know this is a binary acid. So all you have to do is determine what fluor means, which is fluoride, and you have your formula here. And then you have chloric acid, and you know 8 goes to ic, so you're looking for chlorate as your anion. And see here, chlorine is in the elbow, so it's going to have 3 oxygens. And here's your acid here, because chlorate has a 1- charge, and it'll cancel out that. And now next we have hypochloric acid. And remember, chloric acid had 3 oxygens, so hypochloric is going to have 2 oxygens. And then, of course, the charge will cancel out again, you'll have HClO2. And then you have perphosphoric acid. And remember, 8 goes to ic, so phosphate has 4, as we determined before, 4 oxygens. And the per adds 1 more, so it's phosphate with perphosphate, which has 5 oxygens. So simply put that in, and we know the charge is 3-, so we'll crisscross charges to get 8,3PO5.